Good morning, everybody. Welcome. Welcome to the Spring 2026 Jaki Lecture. My name is Jamie Boulding. I'm a professor, a theology professor in the seminary here on campus. It's great to see so many people here. So we are here for the Stanley Jaki Lecture for the Spring 2026 semester. So this is a lecture series that is in honor of Father Stanley Jaki, who was a major figure in the conversation between faith and science in the 20th century. He was a physics professor here at Seton Hall University from 1975 until his death in 2009. He was a physicist by training, also a Catholic priest. And he made some major contributions to the dialogue between faith and science. So here at the university, we have a new initiative called the Stanley Jaki Academy for Theology and Science, in which we are honoring his life, his work, and his legacy in many different ways, with courses, with research projects, with a project at the library digitizing his archives, which we have in the library here on campus, and also hosting these lectures each semester. So I'm delighted to say that this semester's Jaki lecturer is Professor Nicholas Teh from the University of Notre Dame. He is a philosophy professor there, completed his undergraduate studies at Princeton and his Ph.D. at the University of Cambridge in the UK. He specializes in philosophy of physics. I will let him introduce and frame his topic and his remarks, but many of the themes he's going to be talking about today bear directly upon the relationship between philosophy, religion, and science. And many of the things he's going to be talking about were relevant in the life and the work of Father Jaki. So Professor Teh will speak for an hour or so, and we'll also have a good amount of time at the end for Q&A. So if you have any questions, thoughts, reflections forming in your mind during the lecture, we will try and address as many of them as we can before we finish at 1 p.m. We also have refreshments at the back if anybody would like to partake. So with that, please join me in welcoming our Spring 2026 Jaki lecturer, Professor Nicholas Teh.
Thank you, Jamie, for the very generous introduction. It's such a pleasure and an honor to be giving this lecture in honor of Father Jaki. I knew Father Jaki a little bit when I was an undergraduate at Princeton. He was actually residing in Princeton. And one of my early recollections of Father Jaki was running into him in the library, and he had seen me at Mass. So he was at least acquainted with me in that context. And he called me over and said, "What is your major?" And I said, "Physics." And he said, "Do you know Latin?" And I said, "No." And he said, "Why do you not know Latin?" And I said, "Well, I was a little bit defensive. I said, I intend to learn Latin." And then he said, "My son, the road to hell is paved with good intentions." And I still don't know Latin. But I guess the intention is there. The topic of today's lecture is the work of Pierre Duhem, who was a late 19th century, early 20th century physicist, and also historian and philosopher of science. And he was one of Father Jaki's great heroes. Father Jaki has a biography of Pierre Duhem, and while it's not quite a hagiography, I think it's certainly fair to say that it's extremely positive. And I think speaking about Duhem is a great way to honor Father Jaki, because Father Jaki very much walked in Duhem's footsteps, both starting out his career as a physicist and then making seminal contributions to history and philosophy of science. So what I'd like to do today is to begin by talking to you about Duhem's magnus opus, this tome, The Aim and Structure of Physical Theory, which in these slides is abbreviated as ASPT. Also, again, the aim and structure of physical theory. It's a culmination of decades of his work in history of science and the philosophy of science, and also his agential practitioner's perspective as a physicist. The main claim in the aim and structure of physical theory is that the activity of doing physics, and we can generalize this to science, has a form and it has an aim. And I'd like to speak to you about how to think about what form and aim mean here. They're clearly very Aristotelian-sounding words. And Duhem meant them in that context. He meant to use them with an Aristotelian valence, Aristotelian resonance. And the second part of the talk, I'm going to appeal to the work of Elizabeth Anscombe to try to give a more detailed exegesis of Duhem's insights in the aim and structure of physical theory. And finally, at the end, we'll return to the aim and structure of physical theory, Duhem's magnus opus, and explore some analogies with art and try to draw out why Duhem's work really matters for us. And the upshot, I claim, is that the case of science, we will see from Duhem's work that the case of science is really an exemplar of humanistic thought and knowledge. So that's what I want the moral to be. Before I proceed, it'd be helpful for me to know how many of you are at least passingly familiar with this book, The Aim and Structure of Physical Theory. For many years, for many years, it was a paperweight in my office until I ended up teaching a graduate seminar. It's big, and it's dense, and because he's trying to explain what physics is, it's full of equations and detailed accounts of what physicists do, the rational reconstruction of what physicists do. So there's a lot of detail there. And I'm going to abstract away from a lot of this detail to try to give the main insight today. There is an exegetical move here, there is an interpretive move here, and there certainly is room for debate and argument about whether this is the right exegesis of Duhem. I'm going to try not to get bogged down in those debates for the purpose of today's talk. But that said, feel free if you want to challenge the exegesis, or if you have questions about how the exegesis could have gone differently, feel free to ask those questions. I'm also going to invite you to ask any clarificatory questions you might have in the course of this talk. So if something seems obscure, or if you'd like an example, don't hesitate to ask. So, in memory of Father Jaki. Let's start with, I think, a large part of the motivation for Duhem's aim and structure. And this was an exchange between Duhem and an intellectual named Miguel Rey in the pages of a journal that was started by Duhem's friend, very close friend, Maurice Blondel. So perhaps that might be a name that's more familiar to those of you coming from theology. Blondel was a theologian and actually started out as a philosopher of action. And his seminal work is a study of action, human action. I think it's the third or second chapter, is a treatment of science in the context of human action. And Blondel and Duhem were very close. I think they were close from the time they were undergraduates at the École. And although this aspect of Duhem's work hasn't really been explored in literature, it's hard not to think that Blondel's work on action deeply influenced Duhem in some way in his writing about the structure of science. Anyway, so back to this debate between Duhem and Rey, exchange maybe between Duhem and Rey in the pages of Blondel's journal. Rey writes an article summarizing Duhem's history and philosophy of science. And Rey terminates the article as follows. Our intention here has been, to examine only the scientific philosophy of Monsieur Duhem, and then I'll skip over the rest of the passage. He ends with respect to an integral scientific skepticism, Duhem's scientific philosophy is that of a believer. And Duhem was horrified at this. He was not horrified at being pegged as a believer. That wasn't the issue. He was horrified that his scientific philosophy would be thought to be uniquely determined by his being a believer in the following way. So let's go to Duhem's response. So Duhem then writes, "Of course I believe with all my soul in the truths that God has revealed to us and that he has taught us through his church. I have never concealed my faith," and so on. And then he says, "But surely it is not in the sense that Monsieur Ray meant the formula by which he characterized his physics. Rather, did he mean that the beliefs of the Christian had more or less consciously guided the criticism of the physicist, that they had inclined his reason, the physicist's reason, to certain conclusions, and that these conclusions were hence to appear suspect to minds concerned with scientific rigor, but alien to the spiritualist philosophy or Catholic dogma. In short, that one must be a believer, not to mention being a perspicacious one, in order to adopt altogether the principles as well as the consequences of the doctrine that I have tried to formulate concerning physical theories." So to paraphrase, Duhem saying, my philosophy of science can be accepted by anyone with a right-minded view about science. It doesn't rest on any dogmas of the faith. It doesn't rest on any uniquely theological positions. Right? And then he continues, "If that were the case, if what Ray says is true, I should have been singularly pursuing the wrong course and failed of my aim. In fact, I've constantly aimed to prove that physics proceeds by an autonomous method absolutely independent of any metaphysical opinion." And now we see that the scope of Duhem's project is actually even broader. It's not just that he thinks his philosophy of science is independent of theology. Furthermore, he thinks it's actually independent of metaphysics. Now, what does that mean? That's part of what we're going to get into in this lecture. Duhem then continues, "I have carefully analyzed this method in order to exhibit through this analysis the proper character and exact scope of the physical theories which summarize and classify its discoveries. I have denied that these theories have any ability to penetrate beyond the teachings of experiment or any capacity to surmise realities hidden under data observable by the senses." I'll repeat that part because it's tantalizing. Some people are going to think it's offensive, actually, at least offensive to the reason of someone of with a Catholic metaphysics. "I have denied that these theories have any ability to penetrate beyond the teachings of experiment or any capacity to surmise realities hidden under data observable by the senses." So what's going on here? Is Duhem a materialist? Because sometimes materialists say stuff like this, right? Is Duhem an empiricist in the narrow sense, meaning he thinks all that we can know is literally the deliverances of the senses? Again, in some very narrow sense. No, emphatically not. Later on in the book, Duhem explicitly says, I believe in the reality of angels. I believe in the reality of organisms. I believe that organisms are substances. He uses the word substance. In his general metaphysic, Duhem is some kind of Thomist Aristotelian. So that's not what's going on here. It's a very different kind of claim. It's a claim about the way in which science has the power to give us knowledge of reality. Now, he does think that science has the power to give us knowledge about reality, but he thinks it proceeds in a very particular or very circumscribed way, and that it must proceed in this way so that science can be the kind of thing that it is. So far from being anti-Aristotelian, he thinks science has a nature and a function. And it's really a kind of Aristotelianism about the nature and function of science that leads him to this position that, in one sense, knowledge got through science is skin deep. Okay, I'm going to leave it at that for the moment, skin deep, to tantalize you. And we're going to see what's behind this. So Duhem then goes on to summarize in his response to Ray what he thinks and how he got to this view. And it's possible, I think, to gloss over this part of the view as Duhem's autobiography and not of intellectual interest. On the contrary, I think it's foundational to the view that he gets to it in this way. And so this road to it is that, in his words, little satisfied with the exposition of the principles of scientific theories encountered in books. And so books have to, often, a book doesn't just teach you what the theory is and how to use it. Often a book also engages in some kind of meta-narrative about what the theory itself is. Some kind of meta-narrative about the philosophy of the theory. And he says, look, I was very dissatisfied with these things, not from an a priori point of view. Rather, when my students started asking me questions about what the theory is, I found that I could not use the material in the books to answer these questions. And so I was led as a practitioner, based on my experience as a physicist and my experience of teaching physics, to try to say what the science is in a way that makes sense to its practitioners. So he then says, while we tried hard to satisfy their desire, so the we is royal we, the radical impotence of the methods then known for constructing a logical theory came home to us more persistently each day. We then had an intuition of the truths which since that time we have continually affirmed. We understood that physical theory is neither a metaphysical explanation nor a set of general laws whose truth is established by experiment and induction. Right? These being the two polar extremes, he's thinking, in the intellectual space, where people try to say what a physical theory is. On the one hand, some people say, yeah, at the root of it, what science is about those metaphysical realities, the thing you call law. Somehow it discloses to you the metaphysical oomph by which things come about. Things are as they are. And Duhem says, no, not that. And the other extreme is more typically associated with a kind of positivism about science. You say, no, what's going on is that you just have your sense experience, you organize it, and then you perform this special kind of inference that we call induction. You generalize from that store of facts into some, more general, cohesive pattern. And you say, that's the law. And Duhem says, no, not that either. So he's going to try to give you something that's different from these extremes. And then he says something that you might think is confusing because it sounds a little bit like the positivist story. He says, science is an artificial construction manufactured with the aid of mathematical magnitudes. The relation of these magnitudes to the abstract notions emergent from experiment is simply that relation which signs have to the things signified. Now, we've got to be very careful here in hearing science, relationship between signs and things signified. If you're thinking of a very logical version of this, a very formal version, which sometimes is prevalent in analytic philosophy. You're thinking, look, what he means is that the symbols, and then you put it into some kind of one-to-one or many-to-one correspondence with things out there in the world. That's not what he means by this. When he's appealing to the relationship signs have to things signified, or symbols of things signified, he's thinking much more of the way Augustine talks about the relationship between symbol and thing signified. And in the classical authors, when they talk about this relationship, it permits of much more looseness. There can be a holism about the representation, right? The paradigm case, it turns out, of the relationship that signs have to things signified is going to include things like poetry. That includes the relationship of that signs have to things signified. It's not just about the literal. And part of how you know this is where he's going is the way he tries to then gloss this relationship signs have to things signified. He says, this theory constitutes a kind of synoptic painting or schematic sketch suited to summarize and classify the laws of observation. In this analogy with painting, he takes it very seriously. He deploys it over and over and over again in the book, where he's trying to explain to you what science does. And there's different hermeneutic paths here. One hermeneutic path is to say, look, it's a crutch. He's appealing to the layperson's imagination for the relationship between theory and world. And one way to activate that imagination is to bring in this image of what a painting does. Right? But really, it's very different from that. And that's not the way I'm going. What I want to explore is taking the analogy very, very seriously, which I think he does and must. So, interestingly, he is a bit like the positivists in that he thinks this painting or sketch, it summarizes and classifies the laws of observation. But he's very unlike the positivists in that, in what he thinks the laws of observation are. This will come up. He's very unlike them in that he thinks that there is no induction to the laws. There is a mental movement. There is an intellectual movement to get to what we call the laws, but it's not like statistical regression, which is the paradigm case of an induction, right? So think of being given some set of data points, and then you think, oh, there's some inferential process by which now I just determine the best fit line that summarizes the data points. And it really is just a form of inference. So he rejects that view of what laws are. That's not the view. And finally, and all-encompassingly, he's not like the positivists in that he takes this metaphor of painting very seriously. At the end of the day, he thinks what the whole theory does is it represents in something analogous to the way in which a portrait represents, so which representational art represents. All right, good. So this is the book, right? And in the most recent edition, it has a foreword by, the original foreword, it retains that by de Broglie, one of the founders of quantum theory, and the French philosopher Vuillemin, who I think writes a very insightful introduction. The structure of the book is divided into two parts. So part one discusses aim, and part two discusses structure. Or we could say form, right? Aim or telos, structure or form. And here we should be reminded of Aristotle's discussion of action. Aristotle, in discussing action, also says you can't understand action, human action, without knowing something about the end, and without knowing something about the form. The form for him being the practical syllogism, practical reasoning. And I think this gives a key into how to read Duhem. Just as for Aristotle, you should not think that the structure and the aim are separable. Of course, you have to separate them in order to talk about them individually. But in the reality, they're not separable. You can't talk about the form of a human being without knowing something about what the human being's end is. They're related. And the end is also internally related to the form. And the same is true of artifacts. Think of a knife. To know the form of a knife, cutting-like object, is to some extent also to know the end, and vice versa. So in part one, Duhem says that classification is the aim of physical theory. I'm going to say what's meant by classification briefly. Right now, I just want to get the picture, give you some basic placeholders, so you have a picture of what Duhem wants to say. So part one says classification is the aim of physical theory. And maybe at this point you're thinking, uh-oh, sounds a bit like botany. Right? But not really, we'll see. In part two, he then, in this very elaborate way, spells out the structure of a physical theory. So he talks about, we fashion all these symbolic representations made out of the relevant mathematics. He goes into a lot of algebra. And then he says, we apply the right kinds of abstractions to non-scientific descriptions. And these abstractions are the models that get fashioned out of symbols, that get fashioned out of mathematics. They give you these materials for giving a description to various non-scientific descriptions. And he says, well, we do make measurement models, we do error analysis. He goes, we do all these things that physicists usually do, right? The whole life of a physicist. He spits it out at you. And all this is in the service of getting three insights on the table. So the first insight is this, that the aim of science is classification. Again, treat it as a placeholder word for now, and ultimately not ordinary classification, but something very special that he calls natural classification. Insight number two, that there is a kind of indeterminacy involved in performing scientific representation, or in doing scientific representation. And this indeterminacy is really what the contemporary philosophic world has latched onto in Duhem's work. So for those of you who are interested in that literature, it goes by the name of the Duhem-Quine problem. And it's a little sliver of what Duhem means by this indeterminacy. Let me just say, to be concrete, what is this thing that people latch onto? With the caveat that this is such a marginal part of what Duhem is saying, it's really almost epiphenomenal. And it's based on a very quick reading of 2 or 3 paragraphs of a 300-page book and ignoring everything else, right? That's kind of where this is coming from. And what people say this indeterminacy is something like the following. So think of a scientific theory as a set of propositions, P1, P2, P3, and so on. Take the conjunction of these propositions, and together they imply some statement that you can test. Okay? Call that statement S, the statement that you can test. And when you find that the statement is not confirmed or verified, then that implies a negation of not one of these individually, but actually the whole group. Right? So that's just logic 101. If all these imply S, then not S implies not the whole group. And then what people say the indeterminacy is the following. Well, how do you know which one? Right? How could you ever find the culprit for what's going wrong? This thought is, oh yeah, it's kind of perpetually up for grabs because maybe you would like to think that it was this hypothesis that was a bad one that's responsible for the theory not working out. But really, it could be something about how the lab apparatus was set up that day. It could be something you assumed about some other theory, which is typically used in an experiment. Not just one theory will be used, but many different theories. Right? So, example, the fastest way to, at least for the ordinary person, to measure velocity acceleration is use your phone or something and make a little video, and you can count the number of frames. You can compute the velocity acceleration of the object. Right? Okay, so you're bringing in the theory of electronics, electromagnetism, light, all kinds of things. Right? How do you know which thing is being falsified? So there is a little sliver of Duhem that discusses this kind of issue, but it's not really the indeterminacy he's very concerned with. The indeterminacy that he's really concerned with is actually an indeterminacy about action. That's very generic to human action, as we'll see in a moment. And finally, the third insight of Duhem's thought is that correctly describing the objects and the commitments of physical theory, what a theory is about, requires an agential, first-personal understanding of the relevant practice and the traditions and narratives that make this practice intelligible. So this aspect is one that's really been ignored by contemporary philosophy, even though many people pay lip service to Duhem. I think because of the idea that it's pretty scary to think that a philosophy could actually turn on something like correctly understood narrative history, or a kind of philosophical anthropology, right? So to put things at make a first order pass. How many of you are familiar with Alasdair MacIntyre's work? If that's as a reference point for you, Duhem comes really close, I think, to MacIntyre in this third claim. That order to actually do philosophy of science or have a philosophy of science, you need that agential perspective. You need to be a practitioner to some extent. And not just that, you need to understand, you need to have a narrative, a philosophically informed narrative that's grounded in accurate history of your entire discipline. Right? It's going to make a big difference to your philosophy of science, whether you think what we call science began with the Enlightenment, or contrary to that view, if you, like Duhem, and this was a big part of Duhem's work, actually as a historian of science, you think that, no, there is some kind of continuity, actually, between the mechanics that people were doing in the medieval period and Galileo's mechanics. So what Duhem tries to show is that actually Galileo's insights about inertia were deeply founded on experiments that people had done in the mid to later medieval period. Okay, so let's get into this classification business. So earlier I said placeholder. Now I'm really going to try to explain to you what Duhem has in mind by classification. So Duhem says, a theory, a physical theory, but you might say a scientific theory more generally, a theory provides classificatory representations of experimental laws, which are, and these are Duhem's words now, condensed, orderly and useful, facilitate the application of knowledge, and beautiful. Okay, so here I want to back up because I need to start by explaining to you what he thinks an experimental law is. So some people think that an experimental law is something just given to you by the senses, right? Or that you just get it through some kind of induction. Well, it rained 2 days ago, it rained yesterday, it rained today, and then I induced the experimental law. It will continue to rain or something, right? This is not what Duhem thinks an experimental law is. So his favorite example of an experimental law is the kind of phenomenological thing that you might discover in pumping your bike or playing around with canisters of gas, that if you fix the temperature, pressure is inversely proportional to volume, right? So as pressure goes up, volume goes down, and vice versa. So that's the kind of thing he calls an experimental law. But he has a very specific view of how we come to something like this. So here's the view. There's ordinary objects, things, medium-sized dry goods we're all familiar with, this water bottle, right? And he's a Thomist Aristotelian about, as I said, substances, organisms, artifacts. Our knowledge of the reality of these things is actually prior to beginning to do the kind of thing we call science. And now there is something special that you can do that gets you to this thing that he calls an experimental law. Even something as simple as pressure is inversely proportional to volume. Because these words like pressure and volume, they're not ordinary words. They're crafted for very specific purposes. Pressure, you think of Queen or something under pressure. That's not, it's a very high pressure environment, right? And that does not have the same semantic content as the word pressure in physics. Because the word pressure in physics was made for a purpose. It was made to be measured. There may, of course, be, you can do the linguistic analysis. There may, of course, be a relationship to pressure in a colloquial sense. But that doesn't mean it has the same semantic content. Similarly with heat. The word heat in very, very rudimentary thermodynamics, it does not mean what we teach children. It's related to it, but it actually means those degrees of freedom that are invisible to you. We just call them heat. And so even if something like this, if I start talking about, in a serious way, I say, okay, it's pressure, right? If I'm doing science, Duhem thinks, these are very specific descriptions. They're the descriptions that are made to be measured. And what I do is I'm taking the ordinary object and I'm bringing it under this special description. Right? Now I view this. Of course, first I have to be able to view it as a bottle. That's non-negotiable. But now I do something special. I start viewing it as the kind of thing that has pressure. And then I don't really care that much about it being a bottle anymore. Right? It could be lots of things. It's just that this particular thing gets brought under the description of being a bottle. Okay, so an experimental law, let's back up to the point here. An experimental law is not something that's just given to you by the senses. It already involves an intellectual movement through which you bring the ordinary deliverance of the senses under this abstract description. Another example of one of his favorite examples of an experimental law is that the planets move in ellipses around the sun, right? So You might think, that's so basic, well, it wasn't really, but you might think that's basic enough that there isn't much of an abstract description. But actually, ellipse is a very abstract description. It needn't be an ellipse, actually. All kinds of things would be consistent with the data. To even choose to organize data in some particular way, we're already doing the special thing by which we bring what he calls ordinary facts under the special description that he wants to say, now that makes it a consideration of science. The picture, again, the picture that Duhem has is not that here the material world stands apart. And then, we get some input from it and lift it up into some intellectual abstraction. That's not the picture. The picture actually is that we already know the things in the material world, and our minds further extend into it in a limited, particular, and more detailed way, but detailed but limited, detailed but circumscribed, because we re-describe these things in a way that are suited to the craft of science. So that's the picture that he has. And it's from here that he wants to say what a theory does is it provides a classificatory representation of these cases where I'm already re-describing things, right? To say that something's phenomena already means it's been re-described in this special way, actually. And so what does classificatory mean here? Well, he says it means orderly and useful. In what sense? In any sense? No. Actually, orderly and useful for the very specific project of doing science. Which means for him, orderly and useful in a sense that you can quantify things. And orderly and useful in a sense that it conduces towards making predictions. So you could say that Aristotle, in saying that different objects fall at different rates, was trying to classify. But that's much less orderly and useful in context than Newton saying, actually, let's just make the relevant assumption so that different objects are going to fall at the same rate. You see, there is a sense in which Aristotle is actually correct, because this water bottle or this pen and a feather are not going to fall at the same rate. Right? The pen and the feather are not going to fall at the same rate. Sorry. Well, yeah. But that already signals the presence of what are the relevant background conditions? What is the right kind of context to consider these things? And the point here is that Newton's idealization is the orderly and useful classification. Orderly and useful because it's good for making predictions, making measurements that would let you predict. Now, this doesn't mean that, it's not that Duhem has this view that science is like the oracle and, you say to the oracle, where is this going to end up? And the oracle spits out at you a prediction. And then you go, check. And then you confirm it, right? That's not the view. And what makes it different from that is that you've actually got to do the whole thing. And in doing the whole thing, there is a kind of understanding and explanation. But it's the kind of understanding explanation that's correlative to prediction and confirmation and retrodiction. Yes?
you speak louder?
Yes, sorry. So what I said was Aristotle said two things fall at different rates, and you said two things, I'm paraphrasing here, what's more was better because he added the fact that legislative assumption. Did I miss something there, or did he say
Yes,
the
there.
same thing but with the legislative assumption?
Well, it's not that Aristotle doesn't have assumptions too. Aristotle also has assumptions, right? So, but the question is, what is the set of background assumptions that is better for giving a useful classification, right? So an even better example is the first law assumption, right? Which is not typically what we see. Free of external influences, objects will either be at rest or move in uniform rectilinear motion, right? You just don't. When's the last time you saw an object just going around in uniform rectilinear motion? Yeah, I mean, or just completely constant velocity. Just go, right? I mean, and you do see it in pool. You're playing a pool game, but you see it in pool for a very brief period of time. And of course, if you start probing things more deeply, there's some friction, right? That's why it ends up stopping. Okay, so orderly and useful facilitate the application of knowledge relative to the end of this project. But then he gives us more. He uses this funny word, condensation. And one way of hearing condensed is by thinking it's just a synonym for summary in a really algorithmic, bare bones kind of way. There's a different way of hearing condensation, which I think brings us closer to Duhem's meaning, ultimately. And that's the way in which people speak about condensation in poetry. And so when one says that a poem really condenses the meaning of something, right? So take Christina Rossetti, In the Bleak Midwinter. In the bleak midwinter, frosty wind made moan. Earth stood hard as iron, water like a stone. So there is this concentration of image, this juxtaposition and concentration of image that leads us to a deeper meaning. So you can think of condensation like this, in a way that it goes beyond summary because it juxtaposes things in exactly the right way that lead you to the heart of the matter. And finally, he says these classifications are also beautiful. There's something aesthetic about them. All right. This is what he means, I think, by classification being the aim of physical theory. One qualification. Duhem doesn't have a propositional view of what theories are. So I think I mentioned earlier, some people have this view that what a theory is, scientific theory, a physical theory, or you might think other kinds of theories, right, is a list of propositions connected in logical ways and that imply certain conclusions. And Duhem does not have this view. On his view, you represent, of course, parts of a theory using propositions, mathematical propositions, because it needs to be quantitative. But that's not essentially what the theory is. The theory is something you do to represent. The theory is a kind of intellectual product through which you represent something. Something much more akin to the way in which a painting is an artifact that represents. And so for Duhem, a hypothesis is not a proposition. It's a part of a representational thing. And experiments themselves are representations of a certain kind. Necessarily, right? In order to be, because it could only be a scientific experiment if you brought it under the very specific kind of description, like pressure, volume, temperature, that was crafted so that it was repeatable. You could repeat it, and you could measure it, and you could quantify it. So there is this notion of classification we've already discussed. And Duhem also holds that theories, or scientific theories, never give us metaphysical explanations or even directly reveal metaphysical realities. However, and this is what he ultimately thinks the true aim of scientific theory is. He thinks that as scientific theory progresses, physical theory progresses, it can attain not just any kind of classification, but what he calls a natural classification. In his words, a natural classification is the apprehension that the order within a theory is an analogical expression or reflection of an ontological order. That it is an analogical expression or reflection of real relations between the qualities of things. He doesn't give us a lot more than this. And my way into this, into understanding what he is really after here, is to think of how paintings do precisely this. So think of a great portrait. Let me skip. I'll focus your attention by. Right. So it's fairly uncontroversial that Hans Holbein was a great portraitist. And in particular, his portraits of Moore are much beloved. They reveal a lot about Moore's personality, about Moore's bearing and demeanor. And if you go look at the Holbein of Moore, St. Thomas More in the Frick, that's a really famous one, where he has the chain of the Lord Chancellor. This is not this one. Yeah, this is a pretty obscure one. So in that one, Moore has the chain of the Lord Chancellor, and he clearly is robust and really dignified, unshakable will, ironclad will. You really experience the resolve of the man. And this was a study for a family portrait that Holbein did. The family portrait is lost to us, but we have to study. And it's completely different. It's much softer. Right? The image of the man is one that is pensive, actually, very contemplative. Now, so it's very intuitive, very natural to say that paintings disclose, or good portraits disclose to us something of the ontological order. Right? But it's not direct. You don't, see through to the painting, see through the canvas. It's like, aha, there is a substance, right? It reveals to me the substance, the form, rational animal, right? Not featherless biped, but rational animal. That's not how paintings work, but nonetheless, they still reveal to you something of the ontological order, the kind of unity of the substance that discloses itself in personality, right? Not an aggregate. Here lies not an aggregate of flesh and parts and bones, but a person. Right? That's, I think, what Duhem actually is getting at when he says that a theory ultimately aims at being an analogical reflection or expression of an ontological order. It cannot get you directly to the ontological. It is not transparent to the ontological. And this, I think, this is the true meaning of what we earlier read in that Duhem quote, essentially saying that the knowledge given to you by science is skin deep. Well, the knowledge given to you by painting is skin deep too, in the following sense. Any astute viewer of painting knows that he has to go through the superficial way things look on the canvas. Right? There is no road to perceiving Thomas More's personality that doesn't go through close analysis of the stroke, the medium, the techniques, right? To notice who the subject is in the painting is not independent of how astute you are about noticing the design of the painting. You go through the design of the painting to the subject. And that's also shown in this, the Raphael sketch here. So this, I think, in one way we can describe it as a doodle. Not unlike the way you might doodle if you were on the phone and just scribbling around on paper. However, it's also Raphael, so it comes out like this, right? It's done extremely fast. And one of the things you immediately perceive about the character of Our Lady and the infant Jesus is that there is a sense of real intimacy, that there is a oneness. It's a very lyrical sketch. And even though you don't consciously or might not consciously reflect on it in the very moment of perception, if we step back for a moment, it then becomes very clear that this is not separable from our understanding of the line. So think about how the lines interpenetrate each other. And the fact that this kind of impulse of the line could only really come from being drawn very fast. There's a real casualness about the line. And the casualness of the line and the interpenetration of the line, it gets taken up into your sense of the subject. But it's skin deep in the sense that you've got to go through the line. You've got to go through really what is immediately observable in a superficial sense. Right? It's not transparent to the subject. And what Duhem, I think, wants to say is that even though ultimately science is aimed at reflecting an ontological order, it also works in this way, in this very indirect way. Now, aware that I want to leave some time for questions. So I'm going to move quickly through the other insights. So let me move next to this theme of indeterminacy. This one, as I mentioned earlier, one of Duhem's big insights in this book is the indeterminacy of representation. And the way he puts it, anytime I want to bring an object, so a concrete object like this, a real object, under scientific descriptions, under the symbolic mathematical descriptions, there's infinitely many ways to do this. It doesn't matter whether I say the temperature is 100 degrees Celsius or whether it's 100.0000001 degrees Celsius or whether it's 99.99999999999 degrees Celsius. I mean, at least in most experimental contexts, it doesn't matter. And so it doesn't matter for the aims of science. Of course, it's different mathematically. And this is just but one of the most simple examples of a larger phenomenon he wants you to notice, that in doing science necessarily, there's an indeterminacy of bringing objects under the kind of description that would allow you to do science. The point I want to put to you is that this is not generically any different from a similar indeterminacy in action. I want to please my mother on her birthday. Right? So that's a description of my action. I know I'm doing it because I intend to do it. As I start walking to the store, it's already true to say of me, I am engaging in the action of pleasing my mother on her birthday, because that's guiding everything. Right. But now, I've got to bring particular things under the description. So I may not have decided yet. So I'm going to the balloon aisle. I'm going to the cake aisle. I'm going to the butcher shop. What am I doing? Well, all the while I'm trying to please my mother on her birthday. But at least prior to further background information about how I want to do the specific thing, there's infinitely many ways, or at least indefinitely, maybe it's a better word, indefinitely many ways in which I could do this. Right? And then you can go one level up, right? Baking a cake, buying decorations, which is part of throwing a party. There's going to be all these intermediate levels, and at each level, there'll be indefinitely many ways, actually, in which I could bring that description under a bigger description that's connected to pleasing my mother on her birthday. There's an indeterminacy here. And it's actually an analog of this kind of indeterminacy that Duhem is appealing to when he says that this act of doing science is shot through with a kind of indeterminacy. It's really the indeterminacy of human activity and human action. And which is informed by a kind of self-conscious knowledge of what the relevant description is. See, at some point, I might be trying to figure out there might be actually, you think of all these Shakespearean cases, right? At some point, there might be ambiguity about was this an act of fidelity by the queen? Or was it actually an act of betrayal by the queen? Right? Classic Shakespearean situation is that there's a transition where someone thinks that everything that up till now was perceived as an act of fidelity actually turns out to be an act of betrayal. Because it somehow is brought, it fits under a bigger description. That now suddenly makes sense of what's going on. So Duhem wants to say that science is also can be like this. And this is why he thinks that you don't generally have induction when you are improving your theory. The act of going from Kepler's theory, planets move in ellipses around the sun, to Newton's theory, he wants to say, that's not a movement of induction, right? That's not like this regression in statistical analysis. That's much more like my saying, I want to please my mother on her birthday. Well, I'm going to start by getting a cake. And what is this now going to fit into? What is that intermediate step, that bigger description? Right? Because maybe the bigger description is bringing together loved ones and for a party, and the cake is just a small part of that. And the character of buying a cake also changes when I bring it under a bigger description. And Duhem wants to say the character of, it's not that what Kepler did goes away, but the character of what Kepler did gets subsumed under what Newton did. And that's not an induction, right? It's a different kind of thing. It's this peculiarly human capacity to bring one description of our activity under a further relevant description of our activity, knowing how to go on. Okay. So how do we know how to go on? How can the structure of science, the making of better and better representations, be elaborated on in such a way that it conduces towards the aim of achieving Duhem's natural classification? Where, let me remind you of what natural classification is. It's Duhem's term of art for the kind of classification that would be an organization of theory that would be an analogical expression of an ontological order. Right. So, example. You know that there are these theoretical descriptions of gravity. And Duhem would say, yes, that's very convincing, but it's not that that just refers to this metaphysical entity, subtle substance, subtle spirit, gravity, right? Or to space-time. What? No, there really is an ontological order of which this is a reflection, but it's not given to you, actually. Not carved out for you by this, right? What you get is something like a metaphorical reflection of that order. So how can we go about articulating the structure of science? And Duhem approaches this from the agential perspective. So I think it's best summarized with a quote from MacIntyre in 3 Rival Versions of Moral Inquiry. To share in the rationality of a craft requires sharing in the contingencies of its history, understanding its story as one's own, and finding a place for oneself as a character in the enacted dramatic narrative, which is that story so far. Now, this can sound very woo, right? But I think one of the things Duhem wants to urge on us is actually, is there any serious alternative to this? Whether you're doing philosophy of science, or whether you're doing philosophy of ethics, or whether it's some kind of theological reflection, arguably in any one of those pursuits of knowledge, you actually, in fact, have to do this. Precisely have a sense of the philosophical anthropology of that field. Rejecting this kind of move raises the unpalatable option of becoming completely disconnected from your subject matter as a theorist of that subject matter, right? And this, I think, is, without going on to bring in the Anscombe material, this is probably a good place now to wrap up the story. I think the kinds of moves that Elizabeth Anscombe wants to make, and I tell you about them in Q&A if you're interested, they further illuminate a lot of what Duhem wants to say. But let me wrap up the formal story right here. This is what the aim and structure of physical theory is all about. It's all about understanding the structure of science as a canonical human activity and practice, and seeing the ways in which it's analogous to other human activities and practices, which also deliver knowledge, which share in analogous structures, whether that's painting, or whether that's philosophy, or any other thing. Yeah. Good.
Well, thank you very much, Professor Teh, for that extremely rich and elegant presentation. So we have 20 minutes for any questions or reflections in light of what Professor Teh has discussed so far. So I will open it up for Q&A. Okay, great. Yep, and there's a microphone to pass around. Yeah, Jose.
Thank you, Professor Teh. That was very good. I feel I knew a little bit about Duhem, but not as much as I learned now. So my question sort of is trying to understand kind of where he stands as far as in physics. So if we talk about Jaki, in his relevance of physics, he kind of argues that this argument, it seems like kind of emanated from these ideas. That physics or science in general, as you broadened it, has sort of a limit, like a boundary to what it's able to explain and do, right? While like in a lot of physics, there's ideas of like a theory of everything, that it could lead to an understanding, sort of more the Richard Feynman. Feynman lectures. Obviously, he wasn't a philosopher, but he was trying to say that if you understand that everything's made of atoms, you can explain biology, you can explain literally everything with it. So Duhem, from what I'm understanding, basically stands in the relevance of physics sort of camp, that there's a limit to what science can do, similar to what you're saying, like painting or anything. Am I catching that correctly?
Yeah, that's absolutely right. You're definitely putting him in the correct camp. The thing that's really interesting about Duhem is, I think, how he wants to get there, how he wants to get to this position. And he doesn't want to get to this position by some kind of a priori argument. So you see, someone might say, imagine a very different kind of argument. Well, look, physics, here's a metaphysical definition of what physics is or something, right? Or here's a metaphysical definition of the objects of physics. And now I'm going to prove to you that physics has a boundary. Physics has a limit.
Right.
And Duhem rejects this position. Here's how he wants to get there. This actually gives me a chance to introduce some of the further material. Look, consider what I'm going to call practice. So practice is an embodied concrete reality that's shot through with normativity. Sorry, that should be normativity. Practice is a bearer of a tradition. It has its own internal goods that practitioners are oriented towards. So painting is an example of practice. Physics is an example of practice. Right? Now, there might be fuzzy edges around what counts physics, what doesn't. That doesn't really matter. What matters is that, by and large, we have a consensus. People are not generally confused about vocally what physics is. That there is this practice that you count as doing it in virtue of doing certain things, even if you can't give a full list, right? This is why we have physics departments.
Mm-hmm.
And practices have activities that are constitutive of those practices. So there's a practice of tent making. Then there will be things that people do that are characteristic of the practice of tent making. And similarly in physics, again, there's not a lot of confusion about what you generally have to do in order if you want to be hired in a physics department.
Right.
And Duhem would say, let's start, this is where we're going to start. You are in the practice. And his response to someone who's not already, who doesn't want to take the time to be a part of the practice or understand what's going on in the practice is that he's going to say, as he does in his book, he's going to say, well, you really shouldn't be doing philosophy of science. That's the position. He says, so let's start with the practice. And let's reflect on what we need to do in order to fulfill the accepted aims of practice. And these concepts are not random concepts. The concepts like pressure, volume, temperature, why are these things mathematicized like this?
Why do we use certain kinds of functions? Why is it that we accept Newton's theory of mechanics as a basic paradigm for medium-sized dry goods?
Mm-hmm.
It's not because someone gave a metaphysical argument that Newton was right, actually. It's because the way the concepts got developed and refined is really good for prediction, confirmation, and the kind of explanation associated with that. These concepts were made for that. And Duhem wants to, so I'm going to start from here, elaborate the structure of those concepts, and show you that these concepts have nothing to do with metaphysical explanation. And if you read the first part of Duhem's book, he actually tries to go through the history of early modern philosophy. For instance, he says, take a look at Descartes. Descartes mixes up all kinds of statements about metaphysics and what we might consider to be more oriented towards natural science. I'm going to show you, Duhem says, that in every single one of these statements, the part that's actually useful for natural science is the part that leaves out the metaphysics. So what is he doing here? This is a kind of philosophical anthropology, actually. He's basically doing something very similar to what MacIntyre is trying to do in After Virtue, or Three Rival Periods of Moral.
So final point. So would this approach or philosophy of physics it seems to not have been propagated? I mean, a general belief, a more Feynman belief, or I guess a more recent physicist, I guess we can call him that, a Muskian approach is that science is limitless. And the proof's in the pudding in society. So I mean, what would Duhem say to what he was early 20th century, 100 years later or whatever at this point? I mean, what quantum mechanics has led to, the microchip and then leads to artificial intelligence and this whole concept of super intelligence that can explain the entire universe and all this kind of stuff.
Yeah, so there's two very different ways in which you can say that science is limitless. And the first of these ways Duhem is opposed to. So the first way is where you say it's unlimited because it can transcend what Duhem says the boundaries are and get to metaphysics. That's the first way. Right? Tell you fundamentally what human beings really are, what their nature really is. So Duhem rejects this completely for the reasons that we've just been discussing. And of course, you'll say, what Duhem would say is physicists can say whatever they want. Of course, they can, they may not be speaking as a physicist, maybe say I'm speaking as a physicist. But what really tells me whether you're speaking as a physicist in the relevant sense is whether what you say about the limits is grounded in your practical understanding of the concepts you use when you do physics. That has to be the connection. Now, there's another sense of limitless in which Duhem would say, actually, yes, physics is limitless. And this is a very different sense. It has to do now with a general sense in which activities are limitless. So you notice that I distinguish between activity and action. And the distinction I was trying to mark out was the following. An action is something much more specific. It has a very specific end. So I will bake a loaf of bread. I am baking a loaf of bread. This progressive aspect, right? And then the normativity of the action, its unity, it evaporates when I have baked a loaf of bread. The end has been reached, right? It's gone. The ratio of the action is gone, right? It's been accomplished. But take an activity. So something like, I'm a baker. My activity is baking. That's your life. Yeah, that's my life, right? That can go on. There's indefinitely many ways for me to bake. That's subject to human creativity. So it takes that, and science is open-ended in that way.
So life is limitless, he argues in that case.
It was not life, but that
But
the
that
project,
Baker's ability to.
the some kind of project of the creative activity of science. That it can be, it's part of the limitlessness, it can be decided beforehand. You know, there's indefinitely many ways of going on. And we know that it's of course within the limits of the discipline, so it's always going to have something to do with measurement and prediction. It's because it's an empirical science, that's what it does. But you know, whether it looks like string theory or whatever else, who knows? You go on, right? It's not an induction, it's not some kind of rational inference. It's a creative bringing something under a different description.
Yes, very good. Jonathan Heaps, I'm the director of the Bernard Lonergan Institute here. But I was very interested in the connection you drew briefly between Blondel and Duhem.
Yes.
And really, I just wanted to invite you, if you had more to say about that connection, I'd be curious to hear what you have to say. I'll just leave it there since we're short on time, yeah.
So, I don't right now.
Okay.
I mean, I can say something negative. Okay. Sorry, just negative sense of negative space.
I got you, yeah.
Not the sense of critical. Blondel and Duhem write in very different traditions. So, for instance, if you read the chapter in La Science about the incoherence of the sciences, I think it's probably compatible with what Duhem wants to say. But it's, you know, Blondel writes this really florid continental style. And Duhem just doesn't write, it's very hard to make this material mesh. And for someone who wants to work on this project of relation between Blondel and Duhem, which I think is eminently worth working on, the first step would be to go look at the art. There's the Duhem archives in Paris, and they should have all the letters between Blondel and Duhem. And they must have talked about action. So that's what I would say.
That's true.
Well, thank you very much. I'm aware of the time, so we can just one final remark before we wrap. The philosophy never ends at Seton Hall. So if you are interested, at 4:30 p.m. in this same room, in this very room, there is the Toth Lonergan lecture. So if anyone wants to stick around here for the rest of the day, then you're welcome to join that. Otherwise, though, we will conclude here. Please join me in thanking once again Professor Nicholas Teh. Thank you very much.